Reference dependence brings a new way of thinking, and many things are not to be taken in an absolute sense, but how they are relative to the reference point. Well, if you want to incorporate realistic human perception and cognition into your models, and we want to do that, that's how perception works often. So you have to incorporate that into your model. That's what we do in prospect theory. And for instance, one example, if you see a bad loss, that means it is far remote from the reference point. So in many respects, that may be treated the same way as a good gain, because a good gain is also far remote from the reference point. So maybe if people overweight bad losses, they also overweight good gains. One leads to pessimism, but the other leads to optimism. So maybe we should recommend these things in our models. Well, that's what we try to do. I'm talking a bit vaguely now, but you can say for gains, you're looking up, but then for losses, the same thing is looking down. Incorporate that into your models. Well, we'll do that concretely soon to come. But these things, they lead to what is sometimes called reflection about the reference point. Many forms of perception, if they give risk aversion for gains, they give the opposite risk seeking for losses. We have seen already empirically, for instance, in figure 8.1.1, if you remember, where there was a left choice situation, right choice, and then a middle choice situation. The left choice situation was gains, giving prevailing risk aversion. The right choice situation was losses, and it was reflected. It gave prevailing risk seeking. So that's the spirit in which we want to work. Now I want to be more concrete. Let me talk in terms of utility, what we are doing now. We compare here in a comparison. We make a comparison with the utility difference between 1020 and 1010. We compare that with the utility difference between 20 and 10. What would be bigger? Well, everybody agrees, economists, psychologists, everybody alike, that it is, as written here, that between 20 and 10, you perceive that that is a bigger utility difference than 1020, 1010. Now I bring up a more controversial question. Now I go to losses. And then I write it such that the utility difference is always positive. What is bigger, the utility difference between minus 1010 and minus 1020, or minus 10 and minus 20? Now, economists have traditionally said that the inequality isn't that way. They say this is diminishing marginal utility. This minus 1010 and minus 1020, you are way poorer than on the right-hand side. You need money more, so that utility difference is positive, is bigger on the left-hand side than on the right-hand side. Over here, psychologists claim the opposite. Psychologists say it is smaller. They say this has to do with perception, and these numbers minus 1010 and minus 1020 are far away from the reference point. You're not very sensitive there. You feel the utility difference between minus 10 and minus 20, you feel more than between minus 1010 and minus 1020. And maybe if the listener do some introspection, if you think, if you lose 1010 or 1020, is that a big difference? And you feel, no, that's about the same. But if you lose 10 or 20, you feel it as a bigger difference. So indeed, it is quite plausible what psychologists say, but it leads to opposite predictions. Economists have concave utility also for losses. Psychologists say the opposite, utility is convex for losses. Well, empirical studies, no surprise, psychologists are right. The empirical studies, if you do it, measure utility in the right manner, you recommend probability weighting, all these things, then there's more convexity than concavity for losses. So the prevailing finding is utility is convex for the loss domain. You already see this is quite flying in the face of what many classical economic textbooks say. Maybe the economic listeners, when they remember they had the first microeconomic class and expected utility, the first thing that was taught was people are predominantly risk averse. The primary example to show it is insurance, and that means concave utility. And now here you see, well, insurance is about negative body amounts, and now we are claiming, I'm saying here, and it's found, yet it's convex there, not concave. So it's entirely opposite to what classical thinking is, or what your micro teacher then taught you. So, of course, then the question is, how can you explain insurance? I'll return to that question a bit later. But you already see that things become quite different in the behavioral approach. Now, I also want to discuss a bit how it goes with probability weighting, this different approach. In probability weighting, if you look at gain ranks, the ranks for gains, that's the probability of being farther remote from your reference point. Now, the analog of that for losses, being farther remote from your reference point, is a loss rank. So from this way of thinking, you say, if we are using gain ranks for gains, maybe it's more natural to use loss ranks for losses. They will play the same role. And that's indeed what we did in the formula of prospect theory. You will remember for gains, okay, we did the like rank dependent, just work with ranks. I also call them gain ranks. But for losses, we did the opposite what the critics said. We were using loss ranks. Maybe when we did it, you felt a bit annoyed. You thought, oh, they are treating losses differently than gains. They are not using consistent formulas. What is this? And you were annoyed about it. But from this new way of thinking that we should look relative to the reference point, that is how human perception works. Then you start to think, no, the analog of gain ranks for gain, then for losses, it is loss ranks. Both is how remote you are from the reference point. That's what human perception is doing. So then you find the approach that we did with probability for prospect theory. You see that is maybe more natural, more consistent. You're more doing the same way for losses and for gain than what the other approach would do. You will also remember I told you, in a way, it doesn't matter if you use gain ranks or loss ranks. One is dual of the other, just rewriting. So whether for gains you use gain ranks or loss ranks is a bit arbitrary. But the point is, well, if you use gain ranks for gains, then to do the same thing for losses, you should use loss ranks there. You could almost just as well have you use loss ranks for gains, but once you do that, then to be consistent for losses, you have to do the dual, so the gain ranks for losses. That's the more natural way to combine things and to write the formula is more homeomorphic, fitting with human perception than any other way. And that's why prospect theory did it. So if you felt annoyed, now I hope you see it was in fact the consistent way of doing. And indeed, empirical measurements show that if you use the prospect theory approach, then the weighting function for gains is quite similar, almost the same as the weighting function for losses, but that you find empirically. So, but beware that it's crucial here that you use the way of integration as prospect theory does. Had you used gain ranks for both gains and losses, then you would have said, hey, wait a minute, for losses, the weighting function is dual to gains. It's not the same. So apparently probability perception for losses is different than for gains. But prospect theory is more consistent with human psychology, and this way of integration tells you weighting function for gains and losses is about the same, and that's the consistent way of looking at things. If I may speculate a bit ambitiously, maybe on the mathematics, if there is a natural reference point in your scale, then I think the Sipos integral, which is the analog of prospect theory, is more natural than the Schocker integral, which is the classical rank dependent, which will do the same rank for gains and losses. And prospect theory does a dual, like the Sipos integral. Also, I think the formula, the method, I will not show it, but the mathematical formula of the Sipos integral is prettier. So I'm quite in favor of the approach in prospect theory, where we distinguish between gains and losses. But I'll continue on empirical findings to confirm all these things in the natural recording, and the next one.